let's talk about the code 301. Remove invalid princess. So this question give us a string. It may be composed with princess and some other English lowercase English character. It let us to have the minimal numbers steps of remove of the princesses to make the princess balanced. So for string which have princess balance, it must have two conditions. One is when we iterate from the left to right, the left will always greater equal to right. And the second condition is when we finish the iteration, left equals to right. So during the iteration from the left to right, if right is greater than left, then we will have a right move plus. And when we finish the iteration, that may have actual left. So right to remove equals left minus right. So we do this calculation first to get how many right princesses we need to remove and how many left princesses to remove. Then we iterate. We do DFS to iterate from left to the end. So we can use a string builder. We can iterate the string index by index. And if we see it is a left princess, then we are trying to say have this left to remove just a -1. If it is the right princess, we're trying to have right to remove -1. And if we have a left princess equals 0 and right princess equals 0, that is our termination condition. And when we use the all of the actual left move and right move, we may still need to compare whether the string is valid. We still need to make sure that it is valid. The reason is that, for example, we have this kind of condition. So we know we need to have a left to remove equals 1, right to remove equals 1. But if we remove this, right to remove, and remove this, and what is left is this. So it's still not correct. So that just means we finished all of the remove all of the actual left and right. But that means that what we get is a balanced princess string. So after we use out for the DFS, the condition is that after we use out of the left to remove, right to remove, we still need to judge whether the princess is balanced. If it is balanced, then we add it to our list string, our list. So let's write code for this. As we talk about for the another thing is that when we use out of the left to remove and the right to remove, the function to check whether that string is balanced. It's also the same as what we mentioned before, is that when we iterate from the left to right, left is always greater than right. And when we finish the iteration, left equals right. That means they are balanced. So I'm going to have a int called left, which will, is the one when the left parenthesis counts when we iterate from the left to right, and the right equals 0. I'm going to have left to remove equals 0, right to remove equals 0. So for char C yes dictionary, if C equals left parenthesis, that means we need to count the left parenthesis. And if C equals the right parenthesis, that means we need to count the right parenthesis. So if I say right is already greater than left, that means we need to remove one more right to remove. And we also get the right and left to be balanced. And when we finish that, the left may be greater than the right. So the left to remove will be the actual left. Then, okay. So this we calculate how many left parentheses to remove and how many right parentheses to remove. We have some corner cases. So we need to use DFS. For DFS, of course, we need to pass in those kind of results. And at least we need to have a string S, right? We may need to pass some other parameters. S index, right? So means what's the index we already iterate through on the string S, and that to remove right to remove and then we need to have a string builder, right? String builder, because string builder to store the intermediate result, and we need to have the list of string result. So here at the beginning, the index is 0, left to remove, and right to remove, and new string builder. At the beginning, the string builder, we should pass in the S and this string and the result. Okay, so we are say if index equals sb.length, we need to return before we return, no, sorry, not index go to sb.length. We should try to see whether left to remove goes to 0, because we don't need to iterate until if we left to remove already equals 0 and the right to remove equals to 0, then we can terminate. We need to write a help function if is balanced stream builder, then we'll have a result and build to stream. Okay, so this is the termination conditions. So let's iterate the index from index x to the stream builder's length. The rest of the index for int I equals index I smaller than middle length. Plus plus. So first thing is that we need to duplicate, right? And duplicate, dedupe. Dedupe is that if I greater than index and stream builder dot char at I equals stream builder dot char at I minus 1. Then we continue. For this one is that if they are in the same layer of the DFS and the char is the same, that means that this kind of princesses, they are the same. We don't need to do it again. But the thing is that if I equals the index and I minus 1, that is belongs to a previous DFS layer. In that case, we cannot continue because when we delete in the previous one, and now the start of this layer of DFS, we can still trying to do delete or not. So this is dedupe, and let's talk about left princess. If left to remove greater than 0 and be the char at I plus left. We can also have exit conditions. For example, if left to remove smaller than 0 or right to remove smaller than 0 between. We're trying to remove one of the left princess. So let me delete char at delete char at I. And backtracking will be insert at insert index I in the left princess. Okay, so for this one, we do DFS as now. It will be I plus 1 minus 1, because for the at the index by DFS we should go to the next index, but for the index I. So it will +1, but index I, the character is removed, so we will -1. So this index is I here. In the left, to remove -1, right to remove stream builder result. So we do the same for the right. If right to remove greater than 0 in the SB the chart at because in red princess we have SB delete char at I, and also SB the insert I in red princess. And we have a TFS SI. So the same thing. It's actually I +1 -1 because we deleted the char at index I. Left to remove, right to remove -1 stream builder result. We need to write this function where the string is balanced. Let me write this help function. Private boolean is balanced string builder. That is, we also use the left, right, because there. So, for int I equals 0, I is smaller than SB dot length. And if the char at I equals left princess, let's have a left plus as there may have some lowercase in letter, English letter in it, we cannot use else. We just write, we'll have another if, which is the right princess. We have the right. So if, let's say, if right greater than left, then return false. So these calculations, and at the end it will return left equals right. Left. Okay, let's try to see some other test cases. For these questions, assume we have the string length to be n. So assume that the can be left princess, right princess, or lowercase princess. So the worst case that for each princess, we have two choice: delete or not delete. So so there are two power n combinations for each of the princess. If we delete that, we need to do an O n operations like to check whether it is balanced or not. So the time complexity is n, let me write O n multiplied by 2 power n